My name is Dan Bodwin. I'm Manager of Operations, Energy and Utilities for Harvard School of Public Health. The air acuity system is a demand-controlled ventilation system where you're pulling columns of air back to a series of sensors that monitor and measure the indoor environmental quality, then operate the variable air volume boxes that adjust the airflow to the lab based off of those readings or the real-time demand in the space. So traditional ventilation systems are designed with minimum airflows that are typically in laboratories 4 air changes or 6 air changes per hour and up, and they go up from there. And they operate at that, in most instances, 24/7. In our older lab buildings, they're 100% outside air constant volume buildings. So whatever we bring in from the outside, we clean it, condition it, and then exhaust it out of the building. We're losing a lot of potential energy. With the air acuity system, we're able to drive that down lower, much lower. So during occupied times here, we're at 4 air changes per hour minimum, and then during unoccupied times, we can drive it down to as low as 2, which is in our plan for future modification to the system. So in the FXB building, we were able to reduce our carbon dioxide emissions, our greenhouse gas emissions, by 327 metric tons. The energy savings that we realized were around $13,000 for the first year of this pilot on this floor, and then true up through installing the system through this whole building, roughly $127,000 a year in today's dollars, or using today's energy rates, for this whole building.
My name is Andy O'Brien. I'm the Chief of Operations at HPS.
My name is Doug Scatterday, Director of Facilities at HPS.
The building we're in front of, Gallatin Hall, we renovated in 2007. It's originally a 1926 building, but we put a lot of green features into it.
So here we just have aux sensors, which controls the light in the room when someone comes in. It also has daylighting, so depending on the outside light, it'll dim the lights or shut them off. There's also a carbon dioxide sensor, which helps control the controllability of the air handling units. And then we have some lighting scenes also, which people can just get different lighting levels to help us conserve energy. So we had energy conservation competitions, so people could come in, students could come in and pull up different features to see what the electrical use is, hot water, so it just gives them a real sense of where they are in the sense of competition. They can also pull up Hamilton Hall and do the same thing so they can see where they stand. One of the areas that we were hoping to be innovative was in the bedrooms. When we walked into the room, you could hear the fan coil unit start up, and if someone comes in and opens the window, it will automatically shut off the fan coil unit. There's just 2 contacts here on the bottom of the window and on the sill that shuts it off, and now you can hear that it will start back up. When an occupant leaves, the aux sensor notices that, and the temperature will drop 4 to 6 degrees. The lights are also controlled off of the aux sensor.
Since 2005, we've probably dropped our greenhouse gas by 34% for emissions, and our consumption's now down 21%. So in 2011, we're occupying and using our buildings with the same electricity we used in 2001. A decade of consumption has dropped off just by us managing our buildings better.